So again, good afternoon. We're going to continue on solving a few more linear equations. So you're going to, again, get some equations that look like this. Again, our ultimate goal is, when you have an equation, is we're trying to find the value of the letter that makes it a true statement. And when they're real busy like this, it's a good idea to kind of follow some steps here. Step one basically says simplify each side of the equation. And again, we want to look for combining like terms. Or if there's a distributive property, let's use that distributive property to remove parentheses. So let's look at this first example here. And I do see that this left side of the equation has some numbers that can be put together. So I'm just going to bring the letter down, and I'm going to just put these numbers together. A negative 10 and a negative 5 would be a negative 15, and a negative 15 and a positive 4 would be a negative 11. So I see that, or I can go negative 10 and a positive 4 would give me a negative 6, and a negative 6 and a negative 5 would be a negative 11. So I can kind of combine those terms together. This side here, it looks like there's not a whole lot to do. I just have 7x minus 5. There aren't any like terms, and there's no distributive property necessary. So this equation here just simplifies down to this equation. So I've done step one. Step two, get the variable on one side. And again, we want to pick on that little guy. So I have an x over here, and I have 7x's over here. To me, the x is what we would call the little guy. And again, I want to zero them out, so I want to use that opposite guy. So if I see an x, I need a negative x to zero them out. But I need to put a negative x on the other side of the equation as well. So I'll draw my little line there, give myself a little place to start a new equation. So those x and negative x's will zero out. My negative 11 comes in. A 7x and a negative x, well, 7 positive x's and 1 negative x. I'm going to lose an x. So 7x lose an x is going to give me 6x's minus 5. Remember, there's like a negative 1 there. You can treat it like coefficients. A 7 and a negative 1 would give me a 6x. So I've got the variable on one side. My next move now is to get the x by itself. Zero pair and then multiply or divide. So to get that x by itself, I need to get rid of that negative 5. I can add a 5 to both sides. Create a new equation. A negative 11 and a positive 5 would give me a 6. 6x comes down. Those negative 5s drop out. Now the equation really comes to life. If that's a 6, this has also got to be a 6. 6 times what is going to give you 6? Well, you should be able to see a 1 there. 1 would be your solution. You can still just divide each side by 6, and that's going to give you x equals 1, because the 6 is going to divide out, and 6 divided by 6 is also going to give me 1. So x would equal 1. That would be my solution. And if I put that in the problem up here, it should make each side equal. Let's look at this next example. I have negative 6n minus 20 equals negative 2 times n plus 4 times the quantity 1 minus 3n. A lot to say there. But again, let's see if we can follow these steps here. Combine like terms. I really can't do anything over here, but this over here looks kind of busy. Notice how it has these parentheses here. That's what I'm talking about with distributive property. So remember, distributive property means to multiply that 4 through those parentheses. So I'm going to just bring everything else down. Negative 6n minus 20 equals negative 2n plus. Now I'm going to just do this math. 4 times 1 is 4. 4 times negative 3n is negative 12n. And don't forget, this could also be done using that rectangular model. You can write this 4 over here to the side. This could be some scratch work. You have a 1 and a negative 3n over here. 4 times 1 is 4. 4 times negative 3n is that negative 12n. So that 4 and negative 12n become the new terms. So this piece here turns into these two terms. Again, also note that when I remove those parentheses, these two terms can now be put together. So again, I'm going to rewrite this negative 6n minus 20 over here. But a negative 2n and a negative 12n, that's a negative 14n. That's a bunch of negatives. And remember, we talked about coefficients. A negative 2 and a negative 12, that makes a negative 14. And then you bring that 4 in. So I have a negative 14 in, and then you bring that 4 down, plus 4. So that was step 1. Now we're ready to move on to step 2, which is to pick on the little guy. Get the variable on one side. Notice how the variable's on two sides of the equation. The negative 14n is the smaller one. He's smaller than a negative 6. So I want to zero them out with a 14n, as long as I add a 14n over here. So negative 6n and a 14n would give me 8n minus 20, and that's going to zero out, and that's going to give me a 4 over here. So I have 8n minus 20 equals 4. Again, I want to get x by itself, so I'm going to use that 0 pair. So when I want to get that n by itself, so I'm going to move this negative 20 out of the way. So I zero out that negative 20 with the positive 20. So notice how I'm always focusing on the side with the variable, and then working my way the other way. So the negative 20 and 20 divide out, or I'm sorry, zero out. Negative 20 and a positive 20 zero out. I have 8n is equal to 24. At that point, it really jumps out at me. 8 times what is 24? Well, 8 times 3 is 24. But again, you can divide each side by an 8, and that will get that letter by itself. And I would have n equals 3, because again, these 8s are going to divide out. 8 goes into 8 one time, so 1n is going to equal then 8 into 24 would be a 3. So your solution would be n equals 3. And that's our goal, is to get that variable by itself, because once you do that, that tells me what the value is that makes this equation true right here. So if I put a 3 in for n in all 3 spots, if I evaluate these expressions, each expression should turn out to be the same expression in the end. We'll do a few more. Stay tuned.